Hi everyone. So I just wanted to make this video because even though I introduced all the important ideas, I think I could have done a better job at unifying and connecting some of these ideas and sort of emphasizing why these ideas were important. So I thought I'd make a video to do just that. I'm not going to go into every concept into detail. For that, you'll have to watch the videos. But hopefully, this should help with creating a more cohesive picture about why we're talking about all this. So let's start with the classic debate between Thomas Hobbes and Rene Descartes. And so Thomas Hobbes says that we're simply meat machines. What this means is that he's endorsing the mechanistic view of human nature. And more specifically, in this case, he's saying that thinking can be reduced to a purely mechanical interaction or motions of matter. So certain pieces of matter interact with each other, and that this is what leads to thinking. In contrast, Rene Descartes would agree with the idea, sorry, would agree with the idea that we're just meat machines, and he agrees with the mechanistic view to some extent, but he would say that meat machines can't think, and you can't get thinking from a purely um, mechanistic perspective, right? In order to think, you need something else, right? You can explain all other things. In fact, he thought Rene Descartes didn't think that animals could think, and the reason is that he also didn't think they had souls, whereas he thought humans had souls and therefore could think. Yeah, so in the next few slides, or in the next, for this lecture, I try to communicate how the field essentially starts with Thomas Hobbes' mechanistic view, and eventually we'll end up settling somewhere in the middle, a middle ground in which we agree that it's true that all human thought is implemented via the neural substrate of the brain, but we also agree that the mind cannot simply be reduced to brain activity, which is similar to the explanation of how software is not reducible to the hardware of a computer. Yeah, and so yeah, the mechanistic idea. So, following Hobbes' view, I wanted to point out that the main issue is that we have to try to explain something super complex, such as cognition, and we have to do this in a purely mechanistic or mechanical process. And we have to do this all while avoiding the homuncular fallacy. Okay, so we don't want to explain something complex by asserting something that's equally complex. Um, right. And so if there's an internal person who does all the work inside of your head that does the cognition for you, well, that won't work, right? Because then we have to explain why that little person or little entity, how that little entity thinks or perceives, right? So we want to avoid the homuncular fallacy. And then in addition, if we follow this sort of path, it's important to realize that this path has its own set of conceptual hurdles to follow, to jump over as well. So this is what and specifically what I'm talking about is the paradox of mechanical reasoning, right? And so the paradox of mechanical reasoning asks, how do we get meaning? How does meaning get derived from a purely mechanical or syntactic process? And of course, we also need to understand how consciousness arises from a purely mechanical system. And so this is the problem of qualitative experience. And there's also other issues, but those are the ones that I decided to talk about. Uh, and of course, one of the ideas that I talk about is this sort of end run, right? Engineering end run idea where instead of trying to understand how the mind or how natural intelligence works or how natural cognition works, we can just sort of build our own artificially intelligent machine and then sort of compare that to how the mind works, right? But of course, this also has its own setbacks, right? Because even though we're trying to answer this question, the new question that comes about is, you know, how do we know that simulated intelligence is the same thing as real intelligence? All right. So then I talk about theory of computation and computability. Where did I want to leave off here? Yeah, so then I discussed the Turing machine and the theory of computation. And so the significance of this is that um, it shows that complex cognition can, in principle, be explained by a simpler mechanical process. And so, Alan Turing clarified the idea of an algorithm. And an algorithm is just simply an instruction manual that tells you a series of steps that you need to take in order to compute some sort of answer. And with this sort of theory of computation, he suggested that we can then think of thinking as simply computation. Some input goes in, some computation or manipulation of that information occurs. We're just applying steps to manipulate symbols, and then that leads to an output of some sort. And then let's see, and then let's skip this. And then we talk about formal systems, right? So the reason why formal systems is important is because if the mind is a formal system, then we don't have to necessarily need to study the brain. And this is because the rules of the mind are medium independent, which means that they are multiply realizable. And this is where, for example, Mars levels comes into play. We don't have to study the implementational level necessarily. We can just study the algorithmic level, for example, of the mind without having to understand the implementational level. And so if the mind is a formal system, let's go to that. The mind is a formal system, then it shows medium independence. And if it's medium independent, and there are several formally ways, sorry, several formally equivalent ways of instantiating it, then that means it's multiply realizable, which means that strong AI or genuine artificial intelligence would be possible. Okay, and this is consistent with functionalism, which defines things not by the material they're made of, but by their function, how they function. And again, if the mind is not multiply realizable, then strong AI is not possible, or at least it doesn't, it's not quite clear how it would be possible. Okay, and so then I talk about the language of thought hypothesis. Where do I want to stop here? Um, yeah. So the language of thought hypothesis is very complicated. So I don't want you to get too down on yourself if you don't get it. The important thing is that the language of thought hypothesis attempts to resolve the issue of how meaning can be derived from a purely syntactic, rule-based symbol manipulating system. Right. So the question is, how can meaning come about from a purely mechanical process? Jerry Fodor, the guy who introduced this idea, states that we know that there are several formal languages that show what's called soundness and completeness, which just basically means that if something's true in the world, it can be derived using the system, the rules of the system, and also that you can use the system to show anything that's true in the real world. And so if these two logical properties are met, then uh, this means that syntax or the rules of the logical language tracks the semantics. I'll say that again. So if those two logical properties, soundness and completeness, are met, then this means that the syntax or the rules of the logical language can track the semantics. And Fodor calls this language of thought the mentalese. Um, let's see. And so, yeah, we've been sort of following this mechanistic view of Thomas Hobbes, which is normal because science is more in line with the mechanistic view than in sort of the Cartesian way. Uh, and this is all great, right? So, let me get to it. So this is all great. It's like, oh, hey, we're all symbol manipulators, and we can explain the mind as simply following syntactic or logical rules. But John Searle comes in with the Chinese room argument and says, well, not necessarily, right? So the Chinese room argument kind of brings us back full circle to argue that thinking might not be as simple as symbol manipulation, because here's this English speaking guy and he's just blindly manipulating symbols. And so from the outside, it looks like, if you were talking to this guy or talking to this room, so to speak, via this guy, you would you might think he's intelligent, but he's not, right? He's just blindly manipulating symbols. And so, yeah, from the outside, it looks like the system is intelligent, but it's not. He's just blindly following the rules. And so this goes against the idea that all thinking can be simply reduced to mechanistic symbol manipulation. Okay, hopefully that video was helpful. And yeah, that's it.